This is Geometry, Unit 8, Day number 2. We're looking at the circumference of circles and going to talk about pi and where that comes from. We're going to use a piece of string and we'll go across the circle to identify what the diameter is. The diameter is the distance across the circle through the center point. So if that's our diameter, if we lay this diameter out around the edge of the circle, this would approximately be here, and then if we lay it around the circle, it'd be approximately there, and then lay it around the circle, be approximately there. You see that there is a little bit more than 3 diameters that fit around the circle. It ends up being 1 diameter fits here, a second diameter fits to there, third diameter fits to here, and then 0.14 of that diameter fits in here. So let's try it with even a larger circle, a longer diameter. So we'll turn this diameter around the circle, and as you see, lands about there. Lands about there. And if we curve this around, try to be as accurate as we can. Again, we're getting 1 diameter along this edge, a second diameter around that edge, and a third diameter around this edge. This again is not a full diameter, of course, it's just 0.14. Pi, which is actually spelled out as just pi, that equals the number of diameters that fit along the circumference of a circle. So we can look at a formula for circumference. The distance all the way around is always going to be pi times the diameter. And since a radius is half the diameter, if we say 2 radiuses times pi, typically it's in that 2 pi r order. That's another calculation for circumference. Now on the next side, we're going to look for an exact value, and we're going to look for a rounded value for calculating the circumference for this circle, the circumference for the second circle, and for finding the radius of the third circle. So notice that the piece that they give us here is a radius. So if they give us the radius, then we're going to use the formula that deals with the radius. So we'll plug in 8 for the radius, and that gives us a circumference of 2 times 8, which is 16. So 16 pi, and the units would be in feet. We can then use our calculator and say 16 times pi, and that comes out to be 50.27. That's the approximate value. If you would want to use an approximate sign here, you could emphasize that. Notice we don't use 3.14, because if we're going to use a calculator anyway, we might as well use the pi button. Here, notice that they're giving us more than just half the circle. They're giving us all the way across. So with the 13 being in between, that's the measurement of the diameter. So this time we're going to use the formula that includes the diameter for calculating the circumference. So the circumference equals pi times 13. So now we're going to say 13 pi. Typically that would be the order you'd write your final answer in. And this is inches. So that's the exact answer. For a rounded answer, you'd say 13 times pi, and you'd get 40.84. So the circumference is approximately 40.84 inches. For this last one, recognize that they give us the actual circumference and they want us to figure out the radius. So again, we're going to use the formula that deals with radius. We'll put in 65.98 to equal 2 pi r. We don't know what r is. That's what we're trying to calculate. We can either divide them individually. Could divide by 2, then by pi. If we divide by 2 first, we're going to get 32.99. That equals pi times r. Then we can divide by pi, and that would be the exact answer, 32.99 pi. That's the exact answer of our radius. But if we want to know the decimal version, we could take 65.98, divide that by 2, that's where we get our 32.99, and divide that again by the pi to get our 10.5. So the radius equals 10.5, and those units are centimeters. Now if you were going to try to calculate it all at once, you should divide with parentheses of 2 pi. If you don't have parentheses, it will divide by 2 and multiply by pi. You want to be sure that you're dividing by 2 and also by pi. So you get your 10.5 that way. If you don't type it in there correctly, which is a very common mistake, you get a totally different answer. Use parentheses to make a difference. On this next question, minivan tires. How many miles have I driven after the tires have rotated 1,000 revolutions? Well, one thing you would have to know from the day one lesson is that the diameter of these tires is 27 inches. So now with that information, we can go ahead. So that the tires are rotating, and as they spin, as they go around, the circle itself would be moving along. This is for the wheel of the car. So if we know one rotation is going to end up being the distance of the circumference, then we're going to multiply that by 1,000. So we need to figure out the circumference. We know the diameter, so the formula we're going to use is pi d. So we take pi times 27. So our exact answer is 27 pi, and that would be in inches. That's the exact value. You could put that into a decimal if you wish, but really no need to put it into a decimal if you're just going to keep working with those numbers anyway. So that's one spin of the tire. Now let's spin that tire 1,000 times. And of course you get 27,000 pi, and that would be in inches. If we bring over our calculator, we can see that 27 pi ends up being 8482. That's approximately 8482 inches. Well, I'm sorry. That is for 27 pi. Now we're going to times that by 1,000, and that comes out to be, moving the decimal spot over 3, comes out to 84,823. .00. That's actually, after the 1,000 rotations, that's what you get. Now we're going to take this 84,823 and we're going to divide it by 12, because there are 12 inches in every foot. So you're going to take all these inches and group them into groups of 12 inches, and each 12 inches is considered a foot. So now there are 7,068.58 feet. Then we're going to take our 7,068 and some change, and we're going to divide that by 5,280. Up here's a formula that says that 1 mile is the same thing as 5,280. So how many of those groups are in 7,000? So we divide this, and we're going to get 1.338. So we'll call that 1.34 miles. So after 1,000 rotations, a tire that has a diameter of 27 inches is going to travel 1.34 miles. Next, we're looking at a satellite that's going around the Earth. So we can draw in the United States, some funny shape there, and some South America perhaps, and some other European countries, just to give us a globe looking like option. So there's our world, and our satellite is flying around above it. We're going to figure out the speed at which this satellite moves around. It is 200 miles above the Earth. The radius of the Earth is 4,000 miles. So, if we want to figure out how far the satellite is spinning around, and then from there we can figure out how fast it's moving, we're going to have to work with circumference again. Circumference, since we're working with radiuses, we're going to use 2 pi r. The circumference is 2 pi, and our radius for the Earth, it's 4,000, and then 200 more, so 4,200. So now we see that we would have 8,400 times pi. And if we would want to calculate out what that would be in miles, 8,400 times pi comes out to be 26,389. And those are miles. That's the distance that this satellite is traveling. Now, for us to figure out rate, you've heard of a rate formula before, and a common one to use is distance equals rate times time. If we go 60 miles an hour for 1 hour of time, we go a distance of 60 miles. 60 miles an hour for 2 hours, that's 60 times 2, which is 120 for distance. So that's how the distance formula works. We know our distance. Let's use exact answers again. Let's use our 8,400 pi. We don't know what the rate is, but we do know that the time it's supposed to take is 2 hours. These are miles. So we're going to divide. We're going to divide by the 2 hours. Divide by 2 hours. And now you'll see that we'll get 4,200 times pi miles per hour. So that's a rate. That's the speed in which the satellite is traveling. And if you take your 8,400 pi and divide that by 2, that's going to give us 13,194. $13,194.69 miles per hour. So that satellite's whipping around the Earth really fast. Here we have a height of a tennis ball can. It's 9 inches. What is the circumference? What is the distance around each one of these tennis balls? We're not talking about the surface area. We're just measuring a string that might go all the way around in the same plane of a tennis ball. So one way to help visualize what's happening, these would be the tennis balls that are balancing on top of each other inside this can. It's not a snowman. These are your diameters that are going through the inside of the tennis ball. If it's 9 inches tall, then each one of these is approximately 3 inches. So if the diameter is 3, the circumference is going to be pi times d. Pi times 3. So our exact answer is called 3 pi inches. And if we were going to use a calculator, we could say 3 times pi to get 9.42. That's an approximate value. You can use an approximate symbol instead of an equal symbol since it's not exactly. Last question. An indoor track is 70 meters by 140 meters of this rectangular shape. So we have 170 meters, 70 meters, and we're going to continue that all the way around our rectangle. From that rectangle, we also have 2 semicircles that are going around the edge. So when we're going to try to calculate the distance around the whole track, we're not going to go 170 and then cut right down to 70. We're going to go around this curve. So what's the distance around this half a circle? Well, the circumference, again, 70 is your diameter. So we have pi d. Your d is 70. Well, we want half of it. Half the circumference is going to be 35 pi. So now, if that's 35 pi for the circumference and 35 on the other side, our total distance is to travel 170 plus the 35 pi plus 170 again down this side plus the 35 pi again to go around this curve. And that would take you from the beginning, down, around, back through, and around. 4 different steps, 4 different calculations. That's 340 when you add up the 170, 170. That's 70 pi when you add those terms together. Notice you can't add the 70 and the 340 because they're unlike terms. One of them has a pi with it. So 340 plus 70 pi gives you a total of 559.91, and these would be meters.